Hey everybody, welcome to a brief introduction to C Sharp. In this video, I'll be going over the history of the C Sharp language. We'll then look at the features that make C Sharp a great language, and then we'll take a look at the standout features, the things that really make C Sharp shine. We'll then do a code demo where I'll be solving one of the exercises of the C Sharp track and show off some nice C Sharp features in the process, followed by a listing of the resources that you can use to learn C Sharp. I'm really excited about this video, so let's get started. C Sharp was designed and developed by Anders Helsbeck at Microsoft. It was released in the year 2000 as part of the .NET platform, which included the C Sharp language, the .NET runtime, which is a virtual machine, and the .NET framework, which is a standard library. These all have an official specification, and they became an ECMAS standard in 2002 and an ISO standard in 2003. The compiler, the runtime, and the standard library were initially all closed source, but they were open source in 2014. When C Sharp was released, there were inevitably many comparisons to Java, which had released 5 years prior, and as they looked quite similar. C Sharp was not a direct carbon copy of Java, though. For example, C Sharp didn't have checked exceptions, C Sharp did have value types, and there were some neat syntactic sugary things in C Sharp that Java didn't have, like properties and events. C Sharp as a language is strong and statically typed. It's multi-paradigm, so you can program in different ways, although it's primarily an object-oriented language. You can do imperative programming. You can even do a bit of declarative programming, and we'll come back to that later on. And I would argue that C Sharp has become more and more functional too. So you can definitely do functional programming in C Sharp, especially with the later versions of C Sharp. C Sharp compiles to bytecode, where it compiles to an intermediate format, and that is interpreted by the .NET Runtime's virtual machine. That said, ever since .NET 7, which released in 2022, there is native compilation support being added. So you wouldn't compile to bytecode, but you would compile directly to machine code. And this is an ongoing process, but this is improved in each new version of .NET. So where is C Sharp being used in the real world? Well, basically all over the world. It is being used for building websites. It's being used in embedded systems. It's being used to build apps via Xamarin. And Unity allows you to build games in C Sharp. Basically, C Sharp is a language that is all over the place and is being used in many, many real-world applications. Let's go into the reasons why C Sharp is a great language. First of all, it's tooling, which is absolutely fantastic. When C Sharp was released, it was still Windows only, and the editor that you use was Windows Only 2, which was Visual Studio. That didn't mean that it was a bad editor. Far from it. Visual Studio was actually a fantastic editor, and it was one of the reasons why people chose to write C Sharp in, actually, because it was such a fantastic way to write code in. You get everything that you want from an editor where you have, I don't know, a gazillion different refactorings, code analysis. It's all there. Visual Studio is a fantastic editor for code, and it was the primary way in which you wrote C Sharp back in the days. It's still a valid way to do it right now, and I think most people would still use Visual Studio, but with .NET and C Sharp becoming cross-platform, other IDEs have also entered the market, like JetBrains Rider, which is fully cross-platform, and Visual Studio Code, which is also cross-platform. I particularly like JetBrains Rider too, but Visual Studio is excellent too, and even if you want to use Visual Studio Code, you can do that well. Just in general, the tooling around C Sharp is very, very good. A second reason why C Sharp is a great language is that it's expressive, which means that you can do a lot with relatively little C Sharp code. And I'd like to especially mention LINQ here, which stands for Language Integrated Query. And LINQ is sort of like a mini language built into the C# language, and it's especially targeted to working with data. It's almost SQL-like, where you have some data, you want to apply some transformations, maybe you want to do some grouping, some filtering, etc. And LINQ has got you covered. The way that LINQ is designed makes it quite a functional and declarative way to do these things, which means that you don't have to bother with writing the loops, etc. So it's quite a high-level construct to use, and it's absolutely lovely. If you've ever worked with LINQ, you'll immediately fall in love. A third reason why C# is a great language is that it runs almost everywhere. So I mentioned before that you have Xamarin to run apps, so it could run on your phone or your tablet, but you can also use Unity to write games, and those games run everywhere too. But C#, having been open sourced, means that it can run in a ton of places too. So you can use C# to run on embedded systems. Originally, though, it ran only on Windows, and that was why it spawned Mono, which was a free and open source implementation of the C# compiler and runtime, which was cross-platform. So if you worked with C# back in the days and you didn't like the fact that it was Windows only, you did have the option of going to Mono, but it wasn't developed by Microsoft themselves. That changed in 2015 when .NET Core was introduced, which was fully open source and cross-platform. And nowadays, .NET Core and .NET have merged into just .NET. So the thing you have to remember, .NET runs almost everywhere, and it's cross-platform and open source. Closely related to this is that the fact that C# is a true general purpose language. So you can use it for almost any workload you can imagine. So I mentioned games, I mentioned apps, but also a ton of websites run on C#, embedded systems, you name it. It's a true general purpose language, and even if you want to do some high performance computing, C# can help you out with that too. Then another great feature is that the C# has the .NET compiler platform, which is often referred to as Roslyn. So originally the C# compiler was written in C++, but it was later written in C#, and this was part of Roslyn. So the compiler is free and open source, and it's actually a fantastic way to work with C# code. So if you want to parse, transform, or generate C# code, Roslyn has everything that you need. And in fact, we use this extensively throughout the C# track on Exercism. For example, in the test runner, the analyzer, and the representer. But if you ever want to analyze C# code, you want to maybe you want to do some cross project tweaks that you have, like a custom refactoring, you can all do that very, very easily with Roslyn. It's a fantastic tooling to work with. Another great feature of C# is its documentation, which has always been very extensive, detailed, and well written. And that's always a great help when you start out with the language. But even if you know the language well, it can still be incredibly helpful. So the documentation is of a very high level. And then finally, there is a very large community of C# users. It's one of the most used languages out there. So you have many resources available, including blogs, videos, learning platforms, forums, you name it. So there is something there for everybody. Let's look at C#'s standout features. First of all, it has great performance, especially for a managed language. Both the C# language and the .NET runtime have tons of features to help you write the most performant code that you can. For example, C# has a span of T type, which is like almost directly accessing memory, but in a memory safe way. You can allocate things directly on the stack instead of on the heap, which is also can be great for performance. And you get access to all sorts of CPU intrinsics. For example, AVX instructions to run instructions on a bulk of data in parallel. So you get access to all of those. The CLR, so the runtime, is also a very mature, so it has been around for a long time. it's very stable, but it's also highly performant. And there are continuous tweaks that are being made to both the runtime and the language to make it a very performant language. That this has worked very well for C Sharp. You can see for yourself if you look up some of the benchmarks. For example, the Tech and Power benchmark focuses on a web-based viewpoint, and C Sharp is consistently near the top of the list. It's great, especially for a managed language. A second standout feature is a huge ecosystem. So C Sharp is a very big language. It has tons of users, tons of companies using it, and you also get a massive number of libraries that are available via NuGet. So you get libraries for almost anything that you can imagine. And like C Sharp, they've been around for a long time. So you get stable, well-featured. So all the goodness that you expect from a very big and large ecosystem. Then a third standout feature is that C Sharp is a very modern and evolving language. The C Sharp that is around right now is very different from the original first version. So there have been, at this moment, 12 different iterations of C Sharp, and the language has evolved in all of those. So a lot of the things that were added later on, like link was added in C Sharp, I think 4, and then you get async await, you get span of t, as I mentioned before, for memory characteristics, nullable reference types, which is C Sharp's way of trying to fix the billion-dollar mistake of having null in your language. But in general, C Sharp has been adding a lot of stuff and tries to tweak things, and while still feeling like C Sharp. So an example of this is pattern matching, which has been added into the language, but it's been adding in a way that fits the C Sharp language, so it doesn't feel weird. Not only the language is regularly updated, the runtime too. So I mentioned before that there's a thing called .NET AOT, which is compiling ahead of time directly to machine code. And this is being continuously improved upon too. So not only the language is modern and evolving, the runtime is too. So they go together well. And the fourth and final standout feature is that is something that I personally really value, is that there are less alternatives when you use C Sharp. So what do I mean by that? Well, if you start out with a new project, there are usually a lot of choices to be made. Do I use framework X or Y? Do I use editor A or B? You name it. But with C Sharp, you actually usually have less options. And you can see this as a bad thing, but you can also see it as a fantastic thing. So there is no analysis paralysis where you have to, I don't know, do research for months to figure out what would be the best framework to write this in. You can just use the one that Microsoft provides. And this can be really, really helpful because most of the people in the ecosystem are doing this. So the documentation will be focused to that. Resources that you can find are all using the same frameworks. So I think this is personally a great feature of the C Sharp ecosystem. There are, of course, options, but in many cases, what gets packaged and what you could use out of the box, like, I don't know, ASP.NET being the web framework that's bundled when you install .NET on your machine, is just a great framework. So you don't need to look at other frameworks if you don't want to. You can just do what's already in the package. And I personally think that's great, but you can also argue otherwise. But it has definitely helped C Sharp become very valued in company situations, because if you just use the Microsoft supported software, you get, well, support, and you get a lot of people from other places that will have done the exact same thing. So it's easier to hire new people. So it might be somewhat contentious, but I think this is a great feature of the C Sharp language and .NET ecosystem. It's time to do some C Sharp coding. What I'll be doing is to build a solution to the RNA transcription exercise of the C# track on Exercism. This exercise is about getting a DNA strand and returning its RNA complement. And what does that actually mean? Well, so you get some rules. So a DNA strand has a C, a G, a T, and an A. And then the RNA strand has A, C, G, and U. And there are rules that if you encounter a G in the DNA, it becomes a C in the RNA. The C becomes a G, T in A, and an A in the U. So that's basically it. So we are doing a mapping of all the characters in the DNA string to the RNA complements. So that's what we have. The editor that I'm using is JetBrains Rider, which is the cross-platform JetBrains IDE specifically designed for C#. And we have a set of tests here. So empty string becomes empty string, C becomes a G, etc., etc. So let's just run them to see that we're not actually cheating and already have a working solution. And what we start out with is this file. So this is the stub file. It consists of a class. It's marked as static, which means that you can't create an instantiation of this, but we don't need to. And then there is a single method called toRNA that has a single parameter. It's a type string and it's called DNA. So this is our DNA string and we have to return another string. And that's what we need to implement. So the stub just throws an exception that we haven't yet implemented this, but let's change that and let's start implementing our solution. So in our implementation, we need to transform the individual characters in the string. And let's start with a very basic way of doing that, and that is a for loop. And that will be familiar to anybody that has worked in a C-like language. So we do for int I equals 0, and then I is less than. And it's important to know that C# is an object-oriented language. So the DNA parameter is an object, and objects have methods on them. So we can do DNA dot, and that was a way of calling a method. And C# has something that's slightly different than a method. It's called properties. And properties are basically getters without arguments. So we have a length here, so the top one, and length is a property. We don't pass any arguments, so you don't see the regular thing where you do the parentheses afterwards. You just do DNA.length, and that will return a value. So this is called a property. So we can now iterate over all the characters, and we can access them by doing DNA and then square brackets I. So this is the character at position I. So what do we need to do? We need to compare it. So and we need to store it. So let's create a variable string RNA, start out with an empty string, and in the end we're going to return it. And then we need to do the translation. So let me just copy paste this in here so that I don't get anything mixed up. So if the ith character in the DNA string equals a G, then RNA is RNA plus a C. So then we're gonna do a bit of copy pasting. We're gonna do a C to a G, and a T to an A, and an A to a U. Remove this one because this is of course not valid C#. So a very simple solution, just using a for loop. We see that we're using a C# feature called properties here. So a getter only method without any parentheses. Then just regular if else, reassigning the variable with the C added. So let's see if this passes any of our tests. So it passes the test. So this is all great. While this technically works, we can do a bit of refactoring here. So for one, you can see that the editor grays out this RNA, and it suggests that we can convert this into a compound statement. So a compound statement is a thing where you can basically combine two different statements, or a statement and an expression. So we have RNA plus C, which is one part, and then we assign it to RNA again. What we can do is, because the left part is the same here, we can do plus equals, do the same thing here, and that's actually the exact same thing. So we could also use our IDE to compound assignment, and then we get a little bit of help. So that's one thing. Another thing that we could do, and this is personal preference, is we can omit the curly braces. They're not required, so we can get rid of them. Whether or not you like that is personal preference, but we can. And then the final thing is that this is grayed out, and it says that this using system statement is not used. And it used to be used because we had the initial stub with the throw new not implemented exception, which is part of the system namespace, but forget about that. For now, just remember we can remove this, and then we get a bit more nicer code. And let's just run our tests again, and our tests still pass, so that's great. We now have a refactored version that's slightly better, but this for loop is somewhat error prone. It's very easy to make a mistake. For example, do I less than or equal, and then there will be issues. So there is a better way to iterate over a string, and that's via a for each statement. So instead of having this, we could do for each, and then we'll do, we don't do int because we're iterating over the things that are contained in a string, and those things aren't integers, they are characters. So we're going to say char, and we'll call it nucleotide, because I think that's the right way, in DNA. And this will basically mean that anywhere where we did this subscript bit, we can replace this with the value nucleotide. And let's just briefly pause here. For each, what it will do is, under the hood, it will do a for loop for us, but we don't have to write out this ourselves. So you can see here that we don't do anything with edge cases, so we don't have to get the length correct because that's built into it. And this doesn't only work for strings, it works for anything that's what in C# terminology is called an enumerable, so it can be enumerated. And there are collections, of course, can be enumerated, but you can also write things yourselves. But for now, just know that you can use the for each statement to iterate over the characters in a string. So let's run this again. And this is already much better, and it still passes all the tests. So a win. As our next refactoring, we're gonna extract a bit of functionality. So this bit is maybe suitable to a separate method. So let's create it. I think that makes sense. So we're gonna do private static, and it will return in a character. And we're gonna say to complement. So it's the complement of a nucleotide. We pass in a character. So this is the nucleotide. And then we'll write out, we copy this to here. And instead of doing the plus is, we'll just do return. We'll do another return here. We'll do another return here. And then back here, we can do RNA plus is to complement, and then we'll do nucleotide. So let's see, does this work? Well, it doesn't, because we haven't handled all the cases. So what do we do when it's an unknown nucleotide? Well, the best way to handle that would be to throw an exception. So we're gonna throw an argument exception. And we can do a couple. There's an argument out of range. That might be the best one. So it's very semantic. And the first argument is the parameter name. So this is just for getting the error message to be as helpful as possible. So now it all compiles. So, and we'll see if the tests are still passing, and they are. So this looks a bit nicer here now. We can also get rid of these curly braces. Once again, this is personal, but I sort of like that. It also says that we can get rid of these else's because, well, it's basically the same thing. So we can get rid of these. And there's a thing here, it says use a name of expression. So this is the actual name of these nucleotide parameter, but if I were to change it to nucleotide 2, the editor is clever enough, and that's because it's the editor. But in principle, there could be a disconnect. So what you can instead do is use a name of expression, and this will automatically be updated too, and this is safer. So in general, it's recommended to use name of if you ever refer to the name of a parameter or a variable or whatever. So very cool. There is still more that we can do. So this if, it looks a bit like a switch statement to me. So let's convert this to a switch statement. We'll not use the editor. We'll just write it ourselves. We'll do case G, return C. And then maybe we just do case. And we can copy paste this in here. Colon. So a switch statement will probably also be very familiar to people that haven't worked with C# with C-like languages. We'll make this a default just to make it all happen in a single switch statement. Run it. Whether or not you prefer this, it's up to you. But there is a method to this, and that is that we can apply a second refactoring. Namely, this is a switch statement, and a statement is something that has a side effect, and the side effect in this case is that it does a return. But there is no return value of a switch. So I can't do, I don't know, A is the result of the switch. That's not what a statement can do, because a statement never returns a value, even though it has a return statement. But in later versions of C#, there's a thing that's called a switch expression, and expressions always return values. So instead of doing this switch, we can do return, and then we'll do nucleotide switch. So we're switching on the nucleotide value. I'm just gonna copy this bit here, and instead of doing the case, we're gonna do, oh, that was very bad. We're going to do the equals greater than sign. And we have to replace these semicolons with commas. So remove the case, make this an arrow, make this a comma, remove the case, make this an arrow and a comma. And then there's a default one, which is an underscore. It matches anything. Remove that, make this terminate, and then we'll do an indentation. And this is the same thing. So why would you use this instead of a switch statement? Well, I mentioned before that this can be returned. So this returns a value, and whereas the statement didn't. So the benefit of this is that we can return the value, and this is more concise. So previously you had to have either the return or the break in every case statement, but in this case you can just put it on the same line. So this reads a lot better, and it should still all pass the tests, and it does. So that's all good. And there's more that we can do still. One thing that we can do is to use the fact that the C# compiler supports type inference. And type inference is the process where instead of you specifying the type of a variable, you're saying, hey, compiler, you figure it out for me. So we have our variable RNA here, and it's of type string. But the compiler could be clever enough to figure that out by themselves, because this is a string. So it's an empty string. So this must be of type string. So what we can do is, instead of typing out string, we can use var. And this is exactly the same thing under the hood. It's just that at compile time, the compiler says, hey, this is var. So let me figure this out based on the value, which is an empty string. So the type must be string. And you can see if I hover over this, it will still show you that it's a string. And we can do the same thing with the for each loop. Instead of having this as a char, I can just do var. And it knows that when you iterate over a string, you get characters. So every individual item within this for each loop will be a character. Not everybody likes this. I personally really like this because I usually don't care about the types that much. But just know that you can do this. You can only do this for variables. You can't do this for methods or whatever, with slight exceptions. But this doesn't work with regular return types or parameters or whatever. You do have to specify them there. But for variables, you can use type inference. While this for each loop is nice, it's still, well, we have to write the for each ourselves. It's a very common pattern. Isn't there something that we can use that will do this for us? And there is. It's called link. So language integrated query. And in order to use link, we need to import the system.link namespace. And once we do that, we get access to all the functionality that links gives us. So if we do DNA dot, and we'll see which methods there are, we still see the same things, but we also see select, which means map in the functional terminology. You have where, which is filter, and you have other things like group. There is a lot of stuff that link gives you, but you do have to remember to import the system.link namespace. For those of you that are familiar with other functional languages, the terminology is different in C#. The terminology is akin to SQL terminology. So in SQL you have selects and wheres and froms, but in most functional language you would have maps and filters, etc. So do keep that in mind. So we'll just, for now, what we're going to do is we're going to comment out this bit of code. That will be our old code for reference, and we'll start using link. So this bit of for each, what we could do is we're going to use the query format of link, and I'll show you that there is a different format too, where we're going to say from each nucleo, if I can spell it, nucleotide in DNA, then give me its complement. So this is the same thing. The only thing that the compiler complains about is that we haven't assigned this. So we're going to say var complements, because why not? And then this is the same. So this is iterating over the characters in the nucleate in the string, and then returning its complement. So it's an enumerable of characters. We can't just directly return complements because it's an enumerable of characters, and there are different ways in which you can solve this, but let's do a very linky way. So we can say complements dot to array. So now we have an array of characters, and then that is something that we can pass to the string constructor, and then it all works. So it's slightly different. I'm not arguing that this is a better version, but it's a linkier version, and we'll apply some transformation. But for now, just remember that you can use this from in select bit, which is a very SQL-like way of writing code. It's very declarative, so we don't even see the type of the nucleotide here. The return is implicit here, but we get back an enumerable of characters, and to create it into, so to combine that into a string, we have to call the string constructor, and you can't just pass it the enumerable, the compiler will complain, so we have to convert it to an array. And to array is also something that link gives you, so where you can convert any enumerable into an array, and this should still pass the tests. Okay, good. I don't usually recommend people write it this way if they are used to other functional languages. So if you are already familiar with functional languages, you'll be saying, hey, wow, this is very verbose actually. So, but we can change this into something else, because this is the query syntax of link, but there is also a method syntax in link. And the method syntax is where you just call the method. I just showed that there's a select method, we don't have to use the from bit because that's implicit. So we're going to say for each nucleotide in the DNA string, then with the arrow, it's very similar to the arrow here. Then we return its complement, pass in the nucleotide again. I'm going to remove this bit. So, and this might be better readable here. So these two things are exactly the same thing, but this is the method syntax and this is the query syntax. So I sort of like the method syntax better, and this still works. There are some refactoring still that we can do. So one of the things is, by the way, this is called a lambda, and a lambda is like a mini function. So we're defining a function here that takes a character and returns a new character. And the link will do everything under the hood for us. So we don't even say that we're iterating. We're just saying for every character, just do this. This pattern where you have a single parameter that you pass into a function is so common that there is a shorthand syntax. So what we actually can do is we can remove this, and that's exactly the same thing. So now we have a quite short code. I might even go as far as just inlining this. So removing like, so this is now quite a concise way of doing this. So we're going to say transform all the characters by calling the toComplement function, which takes a char and returns a char, and then convert it to an array. I'm going to get rid of this bit, and this should all still work, and it does. So this is now quite succinct, and there is one last thing that we can do to make this even more succinct, and that's the fact that we have a method with a single return statement, and if you do have that, you can optionally get rid of these curly braces. So instead of having the curly braces, we can do the arrow sign. So we're going to do arrow. I'm going to get rid of the return. So this is the same thing as we had before, but it's just written a bit differently. So we're going to say this function returns this value. And because there was only one return statement, we can do this. And we can even do this here because we only have one return statement. It's like 7 lines or 8 lines, but it's still the same thing. So if we do the arrow, get rid of the curly brace and the return bit, it's the same thing. So because both methods have just a single return value, single statement, we can convert that to an expression. So this is called an expression method body. So let's rerun our test, show that nothing has changed. And there is one final thing that we can do, and that is that this new string is also optional because, well, the return value of the function is a string. So obviously, if the only thing that we're returning is this value, it must be a new string. So we can actually get rid of that one too. So let's run it again. It still all works. And this is our final form. So we now have quite a functional version of our code. There are no manual for loops, and there are no if statements. There are no return statements. There aren't even that many curly braces. There's just a couple for the class and for the switch statement themselves, but the methods don't have them. So this is a very functional way, and it shows you that you can use C# in a wide variety of ways with different paradigms, but this is definitely a very functional way, and I would say still idiomatic C#. So I hope you enjoyed that. Let's look at some of the resources that you can use to learn C#. First of all, you can learn C# on Exercism. The C# track on Exercism has more than 160 exercises, but more importantly, it has learning mode, which means that if you go to the learning mode page, you'll see a graph of all the different concepts in C#. And if you follow this, you'll get introduced to the language step by step, and in the end you'll know most of the C# concepts and you know them well. So this is a great way to get up to speed with your C# knowledge. There is of course also official documentation. So this is the official documentation page, and it has basically everything that you ever want to know about C#. So you have language introductions, you have listings of all the different concepts, you have samples, tutorials, you name it. Basically everything that you ever need you can find here. Then there is, if you like videos, there's a C# for beginners playlist. It contains 19 videos and it's taught by Scott Hansman and David Fowler, two people very well known for their C# prowess. And they guide you through basically the very first steps, so your first program, and then you do more later on, so a bit of math, a bit of branching, etc. So C# for beginners is an excellent way to get started with C#. And then C# is part of the .NET platform. So what does that mean? So what is .NET? If you are curious about that question, there's a separate playlist called .NET for Beginners, taught by Scott Hansman and Kendra Havens. And they go over the basics of what .NET is and why should you care about .NET if you are a C# developer. And it's also really helpful. So I would highly recommend these two YouTube playlists to get up to speed with the basics of C# and .NET. And with that, we've reached the end of this video. I hope you've enjoyed this introduction to C# and that you're now keen on trying out C# yourselves. If you do, let me know in the comments what you think, and until next time, bye!